So those are just wait, I will check which problem we have to take. Okay, solve the equation. Simple equation. Okay. Solve the equation. AU decomposition. After that, this method is somewhat complicated. We need to calculate properly, then only it will be possible. So solve problem by relaxation method. So equations are given are 10x minus 2y minus 3z is equal to 205. Okay, so second equation minus 2x plus 10y minus 2z is equal to 154. Third one, again minus 2x minus y plus 10z is equal to 120. Obviously, at the diagonal position, the elements are maximum. I will check the equation. 10x minus 2y minus 3z 205 minus 2x plus 10y minus 2z 154 minus 2x minus y plus 10z is equal to 120. Okay, so we need to first create the residual equation. First part, we need to create residual equation. So Rx, Ry, Rz, we need to create. Simply putting all the terms on the right side. So 54 plus 2x minus 10y plus 2z. 120 plus 2x plus y minus 10z. So first part is over. We need to create operating table. So what will be impact on Rx, Ry by 1? So we need to create a small change of 1 on each value. So obviously, whenever I keep x value is equal to 1, yz will be 0. Yz will be 0. When y is equal to keep 1, definitely x and z will be 0. When z is equal to 1, x and y is equal to be 0. So what will be impact of Rx equation, Ry equation, Rz equation? When Rx is equal to 1, then obviously that will be minus 10, 2, and 2. So these are the residual equations. Then when y is equal to 1, that is 2 minus 10, 2. Z is equal to 1, that will be 3, 2, and minus 10. The third part we have to do is we have to write a relaxation table. Same Rx, Ry. Initially, we have to consider x0, x, y, and z is equal to 0. And we have to reduce that particular part to 0. So when x, y, z is equal to 0, it would be 205, 154, and 120. So maximum value is 205. So we have to operate x value so that it is going to reduce to up to 0. So when 1 is there, it is going to decrease by minus 10. So we have to operate near about 20 times. Okay, so we have to operate 20. So it would be minus 200. So it would be plus 5. Okay, so there I can say 20 into 2, 40, 40, 194. 194. Then 22, 40, 40 plus this 160. Now maximum value is 194. We have to operate by delta y on now 194. By near about 19 we need to operate. To do that, I will take 5 to 6 minutes or max 10 minutes and try to solve this problem. This is one of the easiest problems. So 90% work I have done. Only few operation we need to do. This is only one here. This is 1. 3, 2 minus 10. Okay. Calculate fast. We don't have a time. Take 5. I think I will give max 5 to 6 minutes. Try to solve. User has found 31.92, 25.98, 20.81. Very good. Very good person. Yes, Sandeep also calculated. Is the screen visible to you? Is screen visible? Okay. Okay, Vaibhav has calculated 3124.97 into 20. Okay, near about answer is same. Actually, this answer is this is large value, and even if you don't calculate in fraction value, still it is going to correct. I'm checking whether I can use a full screen. That's why I have asked whether you are seeing mirror image or not. I think there is no option. Okay, so we'll see next problem. I have a new technique with book. That method also you can see. There is a different problem also, and I will teach you this kind of different way. We have created operating table and we have created a relaxation table. Sometimes we need to create operating table along with this relaxation table. Instead, here we need to create some kind of relaxation table also. Here X, Y, Z, and we have to write this way. So this is a small change we have to take. Solve the problem. We take a new problem. So directly write down this problem. We don't have time. We'll directly cover this problem. Just cross check the calculation. Solve the equation by 9x minus y plus 2z is equal to 9. X plus 10y minus 2z is equal to 15. 2x minus 2y minus 13z is equal to minus 70. Okay, so these are the equations, and we will solve this by the new technique. So what we have to create is first write the three equations. Instead of this Rx, R1, Ry, they have written R1, R2, R3. So this is the only change of perception. It could be like Rx, Ry, Rz. Instead of that, we have written R1, R1, R2, and R3. Instead of just doing this minus here, this sign can be, these elements can be moved to the right side. Left side. from the right to left side. So equation, residual equation can be written this way also. Just I am explaining the second way method. Okay. It is not going to affect that I want to explain. So these are the residual equation. Okay. So residual equation, instead of this from left to right, we have done the right to left. So this can be also done. The second part we have to do operating table. So there is some minor change we have to do. Instead of the writing only x, y, z value, so delta x, y, z, we have to write x, y, z value. So write the way I am going to write. So it is the same. Here I have written only one part. Only this part was rx1, y1, and z1. So this part was I have written. Instead of that, delta x1, delta y1. So this way I have written in the previous equation. So here just we have to do a small change. What is that operation? We have to do operation R1, R2, R3. Means the first operation, second operation, and third operation. Obviously, we have mentioned here YZ0. That was implicitly given or we have made. Okay, so only this where we have written delta x1, delta y1, delta z was 1. Now we have to operate on this R1, R2, R1, R2, R3. So that was only change we have to do. Instead of Rx, Ry, and Rz, we have to write R1, R2, R3. So obviously when x is equal to 1, definitely we have to write here 9, 1, and 2. So these are the equations. Don't forget, this is the equation. 9, 1, 2. Okay, then y value is equal to 1 on this particular second operation we have to consider, or it is meaningless here because this is operating table. Whenever we are going to do relaxation table, this operation is going to mean, because we have to multiply 10 times, 1 time. This kind of operation we have to do. So that's why they have said this kind of as a row as a operation. Okay, so -1 here, 10, and here -2. Here 2, -2, and -30. So this was only just writing the operating table. So instead of that, y should we have added Rx, Ry, this 3 row we have written there. Now start with the initial value. X is equal to 0, y is equal to 0, and z is equal to 0. So we'll write relaxation table. Same table we have to write. Same way we are going to do the relaxation table. The way we have written previously. Again, we have to write operation, and we have to keep x, y, z as equal to initial of values. That's why I have written initial values. So x0, y0, z0. So that value will be what? Because this problem is somewhat different. We need to do a multiplication of the we are obtaining. So whatever the answer is going to come, it is not answer is below 1. So answer, whenever we are going to write the problem and the residual values are going to come such a way that it is below 1 or near about 1, then we have a liberty to stop. But exact answer is not going to calculate, and if you want to do exact calculation, this method can be also done. This method, that means doesn't mean that whatever I have taught in last lecture is not can be valid. So that method is can be valid, but we can multiply. Just I will show the how I am going to multiply the 10x. That method can be also applied. This is the second way. If somebody find this is easier, they can adopt, or else stuck to the what I have taught to the earlier method. So okay. So initial value is x, y, z 0. So answer will be what? -9, -15, -9, -15 here, -15 and 17. Okay. So first operation we have to do is we have to find the largest value. Largest value is by default it is a 17. So 17 means z operation we have to do. So near about I think one value we need to calculate. So one time this value is going to subtract 13. 13 into 2, 26. So we don't want to reduce on the particular sign going to come negative. So here instead of that particular x is equal to 1, we have to write R3, 1 R3. And 1 means you cannot means it is possible. It is you can write that particular one number, or it is by default it could be written. But what can be written, because we need to sum that particular sign. By default, if you don't write the numbers there, so you may forget to add the particular number. So write the 1 R1. So 1 R1 means we need to do operation on this 1. So that means 1 1 1 0 0 1. So 2 minus 2 13, that will be added. 2 minus 2 13, one time it will be added. I will write the particular -7, -17 and 4. So this is the one. This is a one calculation. Second calculation. Now by default, 17 is the largest value. We need to do 2 R2. That means y value. 2 R2 means y value. So I will write the table again. Because this value is 17, here by default it is going to reduce 10. So 10 into 2 20, 20 plus, that means sign is going to come plus. So you can have a judge that particular 17 number, it can be reduced to by reducing the 10 number, it is going to come 7 or it is going to 3. So if you operate 2 times, it is going to reduce by 20. If you operate by 1 time, it is going to 10. So obviously 3 is a lesser number. That's why we have to do a 2 times, 10 into 2. 10 into 2. This is a 10 number. So we have to operate 2 R2. 2 R2. So just I have said that the sign should be somewhat lesser. So if you have reduced by 1 time, it is going to 7. If it is 2 times, it is going to come 3. So we have to judge. You have to judge the particular number, how many times you are going to reduce, so that, and obviously this is a -17 sign, we are going to add a 20, and that is why the plus sign is going to come. That's why we have to do a 2 times 2y. 2y, that means 2 R2. So 2 R2 we have to operate and we have to write the sign. We don't have time, so that's why I have written going to write fast. -930. Again 9 would be largest. At R1 you have to operate. Okay, so R1 101, that is 042. So first operation is over here, but you can see 042. The sign is somewhat near about 0, but exact solution we have not obtained. So near about, I can say from this sign, x should be 1, y should be up to 2, and z is equal to 1. So this answer we can obtain from the initial table. X is equal to 1, y is equal to 2, and z is equal to 1. So now second method is that we have to multiply this whatever the remnant into 10 times. We have to multiply this remnant into the 10 times. Okay, so multiply the particular. Okay, so this 1, 2, 3, 4. So I have to do a summation that particular 1, 2, 1, here 0, 4, 2. So this is the fifth sign. fifth equation, and we have to multiply the fifth by 10 times. Multiply it would be 10 times. So what will happen? It is 10, 20, 10, 0, 40, and 20. So don't forget about that. We have multiplied by 10x here. Multiply by 10x here, because this how many times you are going to multiply 10 times, that will be considered. Now we have to operate on this table. Operate, or rather we have to reduce this up to 0. So 0, 40, 20, that means 40 is the largest value, and we have to operate by one value is going to reduce by 10, so we have to operate by 4. Obviously this sign is positive, this sign is positive, that means minus 4r2, minus r2 sign we have to apply. Okay, so I'll write the table. 0, minus 4, 0, 4 times, minus 4r2, minus 4r2, minus 4, 0, minus 4 into multiply of this term, and we have to add in this particular terms. Okay, that sign would be a 4, 0, going to come 28. So this is a 6, this is a 7. Then this is the largest value would be this would be reduced to R3, to R3, to R3 means 0, 0. Z value would go to 2. Write the value 8 minus 4, 2. Okay, then first number is largest, that's why. And to reduce by 4r1, that is minus 1, 0, 0. Minus 1 I have taken. Minus r1, minus 8. Okay. So that will reduce minus 1, 1, 9, minus 8 minus 9, 8 minus 9 here, that will be minus 1, minus 5, and 0. So again these numbers are near about 0. So that's why again we have to do this kind of operation. This kind of operation. That means we have to multiply by 10 times. So but we have to sum these all the terms. 7, 8, 9 equation, 9 equation, 10. So 10 equation again we have to multiply by 10 times. So we can sum this 10, 10 minus 1, 9. 20 minus 4, that will be 16, and 12. We have to sum this particular part. 9, 16, 12. So that would be minus 1, minus 5, 0. Okay, so 10 times here we have to multiply by 10 times. That would be, what will happen? 90. Now we have to consider this 90, 160, 120. Here 10 times we have to do 10x. Second 10x we are going to operate 10x. So again this sign would be 10 times, minus 10, minus 50, and 0. Now this minus 10, 15 that we want to reduce. I don't have a table, but how can, is it visible to you? Yes, you can see that part also. So just I am wiping out this particular sign so that you should understand. 10 times I have done. 10 times, here I have multiplied 10 times. Here I have multiplied by 10 times. Okay. So operation x, y, z, r1, r2, r3. So what were the remaining terms last time? That was 90, 90, 160, 90, 160, and 120. The remaining were minus 10, minus 15, minus 10, minus 15, 0. Now we have to reduce this term by 0. So again we have to do operation. So this is the value by 1. By 1 it is going to reduce by 10. So 5r2. Right here 5r2. So 5r2 0, 5, 0. That is going to reduce minus 50, 0, minus 10. I'm not writing the equation, but whatever the equations are there, just add the equation because it will be important at the last time. So 15 is the largest one, 2R1, 2R1, that is 200, 32, and minus 6 would be going to remain. The largest value is 6, but single value is going to reduce by 13. So again we have to do a multiplication of 10 times. Here we can operate on the R3 also, but one R3 is going to reduce by 13. That's why we are stopping here. Instead of that, again we are multiplying by 10 times. So before that, do the calculation. 92, 165, 120. It is 3, 2, minus 6. Now here multiply 10 times. So that will be 9, 920, 1650, 1200, and here will be 30, 70, and minus 60. Now we have to operate this table again. 10 times. Wherever this kind of sign come, you multiply 10 times. So just consider 10 times we are going to consider. Whatever the value is going to come, that will be not x. It will be 10 times 3x, 10 times 3y, 10 times 3z. This was only change we have to do at the last, because 10 into 10 into 10, 10 raised to 3. So whatever the sum we are going to generate, that is not exact sum, that will be the 10 raised to 3, because this 9 to 0 is going to come 10 raised to 3. Okay, so reduce this particular table again. So largest value is again 60. We have to do operation 5 R3. I'm going to write first 005 minus 5, 20, 30, 20, 30, and 5. Again, largest value is 30. Y operate minus 3 R2. Again, 0 minus 3, 0. That value is going to come 23, 0, 11. Just check. This is simple calculation. Just we have to do the minus 3 times. Largest value is 30y. So R2 is going to 10 times 10 into 3, 30. Like that we have to operate. That is not difficult thing to explain. Minus. Now largest value is again now 73. This value. So we operate on the R1. So R1 minus 3, 0, 0. So this value is going to produce minus 4, minus 3, 5. Now 3 times we have done the multiplication. That means whatever the fraction is going to come, that is not 4. That will be not 4. This is not 3. Not 5. So this is a negligible value. Here about 0 value. So we have a liberty to stop here. We have liberty to stop here. Now you have to do the sum. Whatever the sum you calculated, that we need to do. So this part it is going to important. Whatever the calculation we are going to do. So 192 minus 3, 917 here, 6147 and 1195. So these are the remaining values. But this is whatever the x value, y value, and z value. Whatever the sum 917, 1647, that will be not single x value. That will be 10 raised to x, 10 raised to 3. That 1647, 10 raised to 3, 10 raised to 3. Z value is equal to 1195. Now we have to find out the x, y, z value. X, y, z value. So 10 raised to 3x, 917. So that means 1000. 1000 divided by 917. 1000 divided by 917. So answer would be what? Answer is simple. Divide by 1000. So 3 decimal we obtain. 3 decimal point we obtain here. 1.647 divided by 10. 1.195. So this will be the final answer. So write down this particular problem also. This way we can solve the problem also. Take few minutes, write this particular problem entirely.